Right, gents, tonight's session, when you're ready. On the front sheets of your handouts for the week, there's a little bit of a drill around those two graphs on the screen there. What I want you to do, just 2 or 3 minutes. The one on the left is two simultaneous equations plotted. What does it mean? Think about what it means to solve two simultaneous equations, and also, if you can, indicate with an arrow the point that describes the solution to those two equations on that graph. And then on the right hand one, that's a graph of a particular quadratic equation in the form of, it's got an x squared term in it, as well as other things. What does it mean to find the roots of that equation, and also indicate on that graph where the roots are? And lastly, how many real roots can a quadratic equation have? So a couple of minutes to have a think about those questions, and then we'll have a chat through it, and clearer answers will come as we go through tonight's session. Right, guys, so George, put you on the spot. Where on that first graph would I indicate that is the solution to those two two simultaneous equations? Simultaneous. Where the two lines meet, yeah. Where the two lines meet. Where the two lines meet. They are lines of those equations. Where they meet, it's a solution. So the solution would be that x is equal to about 1.5, y is equal to 4. Okay? What it means is to find the two values for y and x that satisfy both equations. That's what it means. Yep. What about a quadratic? Stuart, what ideas have you got around which? How could I indicate where the roots of that equation are? Here? Okay. Anybody else go for that? Yeah. You changed your mind, Adam, have you? You just said you went for that. Or are you saying you went for something different? No, that you're saying there and there. When I asked, did anybody else go for that point at the bottom there? The bottom of the curve. You said yes. Put your hand up. Alright? Now you're saying the points where it crosses the x-axis, you would be right. Okay, it's the value of x when y is equal to nothing, if x and y are the variables that you've used. Okay? So, how many roots can a quadratic equation have, Toby? Can have 2. Anyone got any different answers? Can't have 4. It can have 1. Or 0. It can have either 2 roots, like this one has, 2 points where the x-axis is crossed. Okay. It can have 1, which is where this bit here, that point, sits on the x-axis, and the parabola can open above or below. I have one solution. And then if the whole thing sits either above like that or below like that, there are no real roots. It's important to say real, because they could have complex roots. Remember all that work we've been doing with complex numbers? You can use them to describe the roots of quadratics like that, where there aren't any real roots. Okay, so that's just a little bit of a lead in to what we're going to look at tonight. So the plan is to look at solving simultaneous equations, first of all by substitution, then by elimination, so two different methods. Thirdly, going to look at solving quadratic equations by factorization, by the formula method, which is a good method in a way because it always works if there is a solution, and we're also going to have a look at using some graphical software to confirm our mathematical solutions in all 4 areas there. Okay, so that's the plan for the evening. So, first of all, simultaneous equations. It's relatively easy to solve an equation where we only have one unknown variable, because we can do that by rearrangement. So we rearrange the equation so that the variable we're looking for is on the left-hand side, and then we can solve that equation. However, if we have 2 unknowns, then we need 2 versions of the equation for different values so we can solve it. Those 2 equations will be called simultaneous equations. So if we have 2 unknowns like this one, x and y are unknown, then if we're going to solve that, you have to have 2 versions of the equation, and then we do the maths we're going to do now, look at now 2 different methods to solve those 2 equations. So, if you had 3 unknowns, you'd need 3 equations, 4 unknowns, 4 equations, and so on. So generally, that kind of thing's not done by hand because it's somewhat time-consuming. So, the first method. Well, there's 2 methods, substitution and elimination. By solving, we mean finding the value for x and y that satisfies both equations. So we're going to have a look at solving those 2 equations by substitution. I'm going to go through the method, and you have a go, see how you get on. Okay? So the first thing to do is pick one of these 2 equations to rearrange for one of the variables. Which one? Who's going to offer up an idea of which one they would pick and why? Someone's saying 1. Why were you saying 1? Why are you saying 2? Yeah. Yeah, that's why I would pick 2, because y is already on its own. It hasn't got a number, a coefficient in front of it. Okay? So the first step was to rearrange 1 for y. So we got this equation, 8x plus y is equal to 20. What's the first step in rearranging that so we got y on its own? What do we do? Rearrange that equation 2 so that we've got y on its own. You take x from 8x from each side. Subtract 8x as the operation that we do. Yeah. So what we end up with there is y is equal to 20 minus 8x. Okay? And that's that done. So we rearranged the second of the 2 equations so that it's y is equal to something. And we could have chosen x as the variable we rearranged for, wouldn't make any difference. but that one just happened in this case to be the easiest. The next step is to substitute in y equals 20 minus 8x into equation 1, the other equation, for y. So what that means is, write out equation 1, but wherever you see y, instead of writing y, you write 20 minus 8x. So we've got 3x plus 2y, so we put a 2 and then some brackets, 20 minus 8x is equal to 14. Yeah. Now we've got to work with that equation to get it so it says x is equal to something. So what's the first job to do? Get rid of the brackets. So we've got to multiply out the brackets. So we've got 3x there plus 2 times 20, annual, yeah, 40. 2 times minus 8x is minus 16x. And all of that is equal to 14. Adam, next job. Yeah, you can do that. So we got 3x minus 16x is equal to 14 minus 40 is minus 26. Say that again. What's 3x minus 16x? Minus 13x is equal to minus 26. Yeah. Next job.
1x minus 1x equals 2.
Divide by minus 13. Yeah. So we got x is equal to minus 26 over minus 13. Make your mind up. Is it minus 2 or is it 2? It's 2. Okay, so all of that to find out what x is by substitution. Now what we got to do is substitute x is equal to 2 into equation 2. So we've got 8x plus y equals 20. So it's 8 times 2 plus y is equal to 20. 16 plus y is equal to 20. Y is equal to 4. And there's your solution. Solution to those two equations is that x is equal to 2 and y is equal to 4. What we're going to do now is look at how we solve those same two equations by the elimination method. We'll see which one you prefer. Anybody remember how the elimination method works? George, put your hand. Yeah, I kind of understand. Explain to me with that set what you need to do.
So the x, I say what x plus y, I kind of write that 6x plus 2y.
We'll call them 1 and 2 again. What are you going to do? Tell me what you're going to do. Multiply by 2. So you're going to multiply equation 2 by 2. So that gives 16x plus 2y is equal to 40. Is that what you mean? Yeah, we'll call that equation 3. Yeah? What's the next step? Yeah, you said I remember this.
Right. What is that? So you want to make that 3x.
You can't, it's impossible to make, if you multiply that by a number to make that 16x, you're going to change the y. The overall aim here is to get the coefficient of one of the two variables, either x or y, the same. So we've already done that. We've got 2y in the bottom one because we multiplied it by 2. We've already got 2y in the top one. Adam. But what's the operation to make them cancel out?
I'll subtract 1 by 3. 3 by 1, 1 by 3.
I'm hearing a lot of things all day. What did you say? Subtract 1 from 3. I like that idea. Yeah? You could subtract, listen, you could subtract 2 from 1, 3 from 1, but that would give you a negative result. So we're going to subtract 1 from 3 because it's got 3x and 16x. It's going to leave us a positive number of x's. So I'm going to write the other equation under there. 3x plus 2y is equal to 14. And we're going to subtract 1 from 3. So we do column-wise subtraction. 13x minus 3x is 13x. 2y minus 2y is nothing. And 40 minus 14 is 26. Okay? Everyone agree with that? So we got 13x is equal to 26. X is 26 over 13 equals 2. We've found x to be the same as what we did by substitution method. Okay? We would then insert that back into any one of those equations for x and find y. Probably going to choose number 2 because it's already got y on its own. Okay? So they're the two methods. Right. Let's have a look. We'll write out a bit bigger. We got 7x minus 2y is equal to 26, number 1, and 6x plus 5y is equal to 29. So, from what you're saying, Adam, I would guess that you're choosing to get what the coefficient of y the same. Am I right? Yeah. So if you do that, what are you going to multiply equation 1 by? Yeah. So what do we get from that? Multiplying this by 5, what's the result? 35x minus 10y is 130. We'll call that equation 3. And this one we multiply by 2, so that's 12x plus 10y equals 58. Okay? Now, this is testing your ability with the addition of positive and negative numbers. If you deal with that row-wise, so you're going to look at that row and that row and that row separately, what you must remember is these signs here go with that coefficient when you're doing this. Okay? So you do 35x minus 12x is 23. Don't forget the x. X doesn't disappear. It's 23. It's 35x's minus 12x's. Leaves us with 23x. Adam.
I started
If we write it out separately, what we're doing is minus 10, take away 10, equals minus 20.
Yeah, if you plus them, you just get plus 10. Plus
That doesn't get rid of it.
So what do you need to do then? What could you do?
10y plus minus.
Up here, what can you do to turn that minus 2y into plus 10y? Multiply by minus 5. That make that positive.
It doesn't matter if you aim for the y.
You could do the x. Do the x first.
I did sort of time the top row by 6 and bottom by 7, so that made the end.
That make that minus 130. Would you choose that method?
Just
You want me to start again then?
yeah.
Just as useful to go down that route, learn that the best way to go by experience, because that's the only way that you get to know these things is to try them. Look at that. Start again. 7x minus 2y is equal to 26. Number 1. 6x plus 5y is equal to 29. Number 2. Now what we're going to do? Go for the x's, both positive. Yeah. So we're going to multiply the top one by. Multiply by 6, by 7. Who's done it that way? What are the results of doing that then?
I got 42x of y equals y 6. And then the second thing, 2x plus y.
Equation 4.
And then I have another equation.
You done 3 from 4, did you?
Because
3 from 4. So we're going to do that. 40 minus 42x is nothing. 35 minus 12 is plus 47. Why? Yeah, because it's 35 minus 12. The two negatives make a positive, remember, yeah? Everybody remember? So 47y, and then 203 take away 56 is 47. And that's quite simple to see there, that y is equal to 1. Now you can substitute that into either of the other two equations to find x. Right. Oh, I've jumped ahead of you guys, have I? You want to write that down here? The law, Adam, when you're ready. I know you'd like to go home, but you won't get to go home. The law, listen, please. The law connecting friction F and the load L for an experiment is of the form F is equal to IL plus B. What type of function is one that is like F is equal to a constant I times L plus B? What type of function is that? What type of graph would we get if we plotted it? Straight line. It's linear, yeah. It's a straight line. It's in the form of y is equal to mx plus c. Straight line graph. Yep. You got some data on this question. When f is 5.6, L is equal to 8, and when f is 4.4, L is equal to 2. Find the values of A and B, and then find out what f is when L is equal to 6.5. How do we do that? How do we do it mathematically? What are we effectively doing if we graph the thing? We need to formulate two simultaneous equations. We've got two sets of data, so we can form two versions of that equation, can't we? It's telling us when f is equal to 5.6, L is equal to 2. So we put 5.6 is equal to IL is equal to 2 times A, because L is 2, plus B. That's one simultaneous equation. I'll pick one off one and one off the other, 8A. And when f is 4.4, L is equal to 2. 2A plus B. How do we solve those two equations mathematically? Elimination, how, Adam? What's the proper word than minus and subtract? Which one from which one? From the top, yeah. 5.6 take away 4.4. A is equal to 0.2. Yep. Then what do? Substitute A is equal to 0.2 into what do I do with that 0.2?
8 times 0.2.
Got to find B. We can't use that equation until we know both A and B, can we?
8 times 0.2.
Into 1 then, yeah? So we go 5.6 is equal to 8 times 0.2 plus B. 5.6 is equal to 1.6 plus B. B is equal to 4. What we've got now is we've found the unknown constants in this formula here, A and B. So we can now write that F is equal to 0.2L plus 4. And then that means we can find what F is when L is 6.5, because we could rearrange that for L, can't we? How do we rearrange that for L? How can we rearrange that for L? Now you're trying to find L. The idea is use the two simultaneous equations to find the two constants. Now we're going to use find the value of F. Oh, sorry, when L is 6.5. So F at 6.5 is equal to when L is 6.5, F is equal to 0.2 times 6.5 plus 4 equals. Do that, please. 5.3. Right. Now check those answers with your graphic calculator. Check those results with your graphic calculator.